Happy day to all. Today we are going to see about ozone thermal electric conversion, which is in energy physics subject. I am Dr. A. Amutha, Assistant Professor of Physics, the Standard Fireworks Rajaratnam College for Women, Sivakasi. Our learning objectives, you can see thermal electric conversion, ozone thermal electric conversions. There are different types of ozone thermal electric conversions, and finally we can discuss about applications of ozone thermal electric conversions. Okay, first, what is electric conversions? Here you can see solar energy which is converted into electric energy. Then one more example, here wind energy which is also converted into electric energy. Then another case, we are using the thermal energy which is also converted into electric energy. Okay, here there are temperature difference that we are using in this picture. Next, we can see here we can see thermal electric conversions. So thermal electric conversion is which is like thermal electric plant. Here we are using the turbine and the steam which is used to rotate the turbine, and which is the turbine is connected to generator which is used to produce electricity. Okay, so finally we are getting that electricity. This is thermal power plant, but we are using that coal here. That coal is used as a fuel. So it may be create lot of pollution, we have to avoid that. Therefore we are going for ozone thermal electric conversions. That purpose we are using that water as a steam. Here sea water, suppose the normal water is the boiling point is 100 degrees Celsius, but in sea water it may be decreased. Why it may be decreased, that also we are going to discuss. So OTEC means ozone thermal electric conversions. Here you can see in the water sea surface the temperature is 30 degrees Celsius, but cold deep water sea water is 10 degrees Celsius. There is some 20 degrees Celsius difference is there. This difference is important for ozone thermal electric conversions. Okay. Next, we are going to discuss about some low pressure. Where is low pressure? Here you can see sea level, the boiling point is 100 degrees Celsius, but in the mountain, the height of the mountain, you can see the low pressure we observed. So in less temperature we can get the boiling water. Okay, therefore we are going for this low pressure concept. Here we are in Mount Everest. The boiling point of water is 68 degrees Celsius in Mount Everest. So but pure water is 100 degrees Celsius. Here we can see the difference why the low pressure is important. Okay. So why we have discussed about the low pressure. Here we are using, this is ozone thermal electric power conversion system. This is open cycle ozone thermal electric system. Okay, here you can see the evacuated chamber. This evacuated chamber which has that low pressure, therefore warm water which may be converted into steam. Okay, the turbine, the steam is passed through the turbine, then turbine is started to rotating. Finally it may be connected to the generator, so the generator is continuously producing the electricity. Here we are using the condenser. Okay, that condenser used to give that change in pace. Meaning what will be happen, the steam which is converted into water. Okay, so that purpose we are using that condenser. Here in condenser we are using cold deep water. So that purpose only the steam is converted into water. That water is called as, you can see, desalination water. This water is used for drinking purpose and agriculture purpose. Okay, so this system is called open cycle ozone thermal energy conversion. Here you can see the desalinated water which is used for drinking purpose. Okay, this is open system. Then wastage from that evacuated chamber and the condenser which may be again injected to that sea. Okay. So this is open cycle system. Here we are not fed back the water to evacuated chamber. Okay, so we need we have to fed back some liquid, some material, suppose water which is used to convert to steam. Otherwise we are using the chemical. okay, that is ammonia. Ammonia is low temperature boiling point. So that ammonia may be converted into steam. Okay, here we have to remove that low pressure system. That purpose we are going for closed cycle ozone thermal energy conversion. Okay, so therefore we are going to, these are open cycle conversion system. This is closed cycle ozone thermal energy conversion. Here you can see we are using the heat exchanger. This may be used to convert warm surface in warm water to steam. Okay, here we are using ammonia liquid, which has a low pressure liquid, which has low boiling point. Therefore we are using ammonia. Here you can see the ammonia is bed back to heat exchanger. Okay, this is therefore this is called as closed cycle ozone thermal energy conversion. Here also we are continuously generating the electricity. Okay, so next what we plant, here there is no desalination water is observed. Okay, we are need drinking water, but it is not observed from this system. Therefore this is one disadvantage. Therefore we are going for another system that is called as hybrid cycle ozone thermal energy conversion. So what is hybrid cycle ozone thermal energy system? Okay, so this is called as open cycle ozone thermal energy conversion plus closed cycle ozone thermal energy conversion, which is called as hybrid cycle ozone thermal energy conversion. Okay, this is combination of these two cycles, which is called as hybrid cycle ozone thermal energy system. Here you can see we are getting the desalination water, and also the ammonia is fed back to that heat exchanger. So these are that the desalination water if we are getting means that is open cycle system. So ammonia is fed back to that heat exchanger, that is called as closed cycle ozone thermal energy system. So both are in that same system, that this is called as hybrid cycle ozone thermal energy conversion. Okay. So here why we are using that OTEC? OTEC means ozone thermal energy conversion. So what I told already, there is a temperature difference between these two, warm water and cold water. Okay, the temperature difference is 20 to 22 degrees Celsius. Okay, so what are the applications? Why we are studying this one? These are used to continuous electricity generation, and also we are getting fresh water, air condition and refrigeration system. Finally we are getting hydrogen production also. More application also available. Okay, so these are important applications for ozone thermal electric system. Okay, conversion system. So from this video what we have learnt, so what is ozone thermal electric conversion and types of thermal electric conversion, ozone thermal electric conversions, and the applications of ozone thermal electric conversions. Okay, this video is very much useful for you. One more important applications, our India is planned to develop ozone thermal electric system in Lakshadweep. Okay, thank you for everyone. Thank you for watching this video.